There are technologies that are game changers. Some are widely visible, such as smartphones or the internet. Then there is DSI, digital sequence information, the result of sequencing genomes or proteins. DSI has revolutionized biological science in a way that was unthinkable 20 years ago and is still largely unknown to the public. But the impact couldn't be bigger. Now, to understand DSI, we have to dive into the principle of any life on Earth. Every animal, every plant, and every other living thing exists because every cell carries a construction plan within, the DNA. The DNA is an extremely long string of 4 different chemicals, commonly referred to as A, G, T, and C. These chemicals are arranged into a genetic code that determines how an organism looks, grows, and lives. To give a little more perspective on how far we've come, the sequencing of the first human genome started in 1984, took almost 20 years and cost over $2 billion US. Now, it takes a day and costs less than a smartphone. The use of DSI offers a wide range of new possibilities, such as finding better cures for diseases, identifying microorganisms that harm plants, adapting crops for climate change, and protecting endangered species. For any of this to happen, the biological resources must have their genes sequenced, and then the sequence information must be stored and made available to researchers. There are 3 public databases where DSI information is stored, one in Japan, one in Europe, and one in the United States. Unlike the unknown number of private data collections, they follow an open access policy and exchange their data daily. Important to know, the bigger the databases, the better. Scientists can now work on projects without necessarily having to travel to a country to collect a physical specimen. This saves time and money. But some countries are concerned that they might lose out on benefits. This has caused international disagreement about the current DSI system. Although the enormous progress made through DSI is undisputed. Let's have a look at some examples. For instance, fish products. It was always suspected that some fish were labelled wrongly. Now, with DSI, it is easy to find out. Take a sample, sequence its DNA, and then compare it with sequences from known species stored in public databases. The more data available for comparison, the better the results. When it matches the labelled product, all is good. If not, it is fraudulent. And investigators have even uncovered products using meat of protected wildlife. This is one example where DSI helps to protect endangered species. Research into pandemic diseases wouldn't be as successful without the global exchange of DSI. Take COVID-19. The rapid development of vaccines worldwide would have been unthinkable 10 years ago. Also, Ebola. For this dreaded disease, there is a vaccine now. A pharmaceutical company developed the vaccine using data previously sequenced and uploaded by others. However, the company has sold these vaccines worth hundreds of millions of dollars only to its own government. And in Africa, where Ebola originates and the vaccine is most needed, it's still not available. DSI also has an impact on agriculture. Stevia, for example, is a plant originating from South America, traditionally used and cultivated by indigenous farmers. It contains compounds over 100 times sweeter than sugar, but without the calories. Selling stevia to developed countries is a big source of income for the traditional farmers. The gene sequences of stevia were uploaded to public databases. It was then used by a European company to create genetically modified yeasts that produce the stevia sweetness, a huge commercial opportunity for the company. But traditional farmers are increasingly being pushed out of the market. This scenario may also be found with products in food, cosmetics, pharmaceutical, and other industries. The world has yet to agree on general rules regarding DSI. Just as with the Internet, technology has evolved rapidly, and society now needs to assess and manage the multiple implications. The question is how the enormous potential of DSI can be realised fairly and equitably for everyone.